Welcome everybody. Thank you for coming to our open day. This is our first open day that we have actually put together a online streaming and in-person demonstration. So bear with us if we have any technical difficulties, but thank you for joining us. My name is Richard. I work here at Tracklab. Freedspace is our company, and our company works as a 3D technology provider, and we have different divisions. So ThingLab, for example, looks after the scanning and printer side of things for 3D printing and 3D scanning. And then Visualab is a 3D visualization part of the division, and Tracklab is the 3D tracking division. So we have the pleasure of working with industry-leading manufacturers and suppliers, whether it's for optical motion capture, inertial motion capture, markerless. We work across biomechanics, robotics, entertainment, engineering. The technology that we're going to run through with you today is the Xsens motion capture systems for an IEMU motion capture, Manus MetaGloves, and the Faceware facial capture system. So we'll go through the real-time process. There's a few studios online that are probably more in the VFX and games industry. What you'll notice is that the process that you'll go through is very similar, but you just might add on some post-processing. So if you want to put it into, rather than real time, you're likely going to export the data and then start to motion edit it in the software that you want to use. The manufacturers that we're going to go through work with all of the major third-party tools. So whether that's iClone or Maya, Motion Builder, Unreal, Unity, they all integrate with all of those tools. The software that we're going to use today is Unreal, and we're going to stream it onto a Metahuman. So it's a really quick and easy way to get performance capture data in real time onto an avatar. Now, the team has actually gone through and customized the Metahuman. Welcome. The Metahuman has been customized to Zara's face. So Zara's actually scanned her face with some of our scanning tools and then customized that rig. Now, our understanding is that the skeleton and the controls on the Metahuman doesn't change whether you've customized it or whether it's out of the box. Someone can correct me if that's wrong, but our understanding is that it's the same. So any of the quality that you see out of the customized mesh that we have, you should be able to replicate that even if it's just out of the box standard Metahumans. Quick one, so the team, we've got Andrew Rouse, who will be taking us through the Manus gloves and the Xsens body systems. Zara Jackson, who will be looking after the facial capture with Faceware. We've got Declan Hughes, who is our resident biomechanics and engineering specialist, who works with these technologies in those areas and is now getting a lot of experience in the entertainment side of things as well. He's kindly volunteered to look after all of the technology in the background. So if anybody needs some help online, feel free to pop a comment in the chat and Declan can help you if he's not trying to do something else. And then Kartik has kindly agreed to jump in the suit. Kartik's actually recently joined our ThingLab team. So he's a 3D scanning specialist and he's going to bow the suit on today. So thank you, Kartik. Before we start, I guess the first thing to talk about is just the way that the day is going to run. So we've got people in our studio, and then there's people online as well. So the people online will go through the process, and if you have any questions, feel free to pop questions into the chat, and Declan will collate them for us. We'll have a section at the end for questions, and we'll use that time to answer any of the online questions. For those that are in our studio, feel free to ask questions during that QA session, but we've actually got some drinks and some food, so you can stick around and have one-on-one, hands-on with the tech as well. So once we end the stream, you're more than welcome to ask more questions and actually play with the technology. So without further ado, I think, Andrew, do you want to take us away?
Thanks, Richard. Declan. Welcome everyone. Thank you for tuning in online, and thank you everyone for making your way into our studio. I'm Andrew. I've worked at Tracklab for just about 2 years now. And since starting, I've been involved in various projects within the entertainment sector. ranging from virtual production through to full body capture and performance. So I've been very fortunate in the cool and interesting technology I've been able to get my hands on. Welcome, guys. So yeah, Kartik, if you don't mind, I'll introduce you to the Xsens MetaGloves by Manus. These are the gloves we're using today. These are magnetic field tracking gloves. So basically, we've got a base here that's emitting a magnetic field, and then these sensors at the fingertips are picking up that magnetic field, and they know where they are precisely in relation to the base here. Now, it is the position and rotation of these sensors, in addition to an inverse kinematic solve within the software, that allows for the output of some incredibly accurate and natural-looking finger animation. So thanks, Kartik. Now that we understand a little bit about how the gloves work, we'll just jump into Manus Core, which is the accompanying software to the gloves. And as you can see here, it's a very simple user interface, and that's because there's really not much to it in terms of getting set up and running with the gloves. Especially with this workflow today, our main priority is just to ensure that each individual glove is paired to the dongle that's plugged in here, over here with the laptop, and that we get a good calibration to Kartik's hands. So we'll get that kicked off. So Kartik, if we've got a calibration already saved on board the gloves. So you don't have to do this every time you log in, but for the sake of education, we'll go through the process. The calibration itself goes through 3 poses, very similar to the Prime series gloves that you might be familiar with from Manus. Slightly different poses, but very short and simple process. So we'll get started. And the first pose, we got hand face down, fingers together, thumbs slightly apart. We want our hand on a non-metallic surface, and we'll begin the process. So we'll look for the load bar around the circle. It might go around a couple of times, but we'll just hold that pose until we get a green tick, and then it will progress to the next pose. The next pose being a fist. We'll just hold the fist. This one usually doesn't take that long to go through. There we go. And the third and final pose, we're touching the palm of our hand with the tips of our fingers while ensuring that the top joint of our fingers remains straight. And we just repeat that pose. This one's the longest of the 3, and we'll just persist as long as it needs. So we'll keep going, and it's happy with that. So with that calibration done, we can see here incredibly natural movement. We can achieve those pinch movements that is notoriously difficult with motion capture gloves. And yeah, it's not pose-based either, so it's not prone to drift over time. And yeah, those are the gloves. I guess I don't know where the ball's gone, but yeah, feel free to. There we go. So yeah, with the gloves all calibrated, assuming that you've got the Xsens gloves by Manus, it will come with a dongle that is prepped for MVN. So all this data will be streaming into MVN without you having to do anything about it. So before I jump into MVN to receive the stream, I'll just talk about the body capture system that we're using today. Now, Kartik's in the Xsens Link system, which is one of 3 inertial body capture systems from Movella's lineup. And yeah, basically inertial capture just meaning we have a series of inertial measurement units placed on strategic locations around the body. Each of these units contains gyroscopes, accelerometers, and magnetometers to measure angular velocity, acceleration, and magnetic field. All of this data is combined on board the sensor through Movella's sensor fusion technology. this process also eliminates any skin artifacts from skin movement or any magnetic interference. All this data is sent through to MVN to continue the calculation and measure the body segments, rotation and movement. So based on the application and the budget that you might be working with, there are 3 different suits or systems to choose from. We also have a Winder system and a Winder starter kit. The primary difference between these ones is they work with a wireless sensor. So these are placed on similar locations around the body. The sensors inside are the same, so the quality of the data and the output is exactly the same, just the application is different. So these sensors will individually transmit their data through a base station to MVN, whereas the link system, we have these little sensors all linked together via cable, routing around to a body pack. Apologies if I'm blocking that. The body pack here will send all the data, thank you Kartik, through this router to MVN. And that is basically the structure of the inertial capture systems. So with that in mind, we'll jump into MVN. We'll start a capture session and we'll prepare this for streaming into Unreal. So we've already got a project open here. We haven't calibrated yet, so it's going to look a bit funky. Before we get into the calibration, I just want to make sure that all the settings are correct. So I'll jump in here, edit our configuration. And what we'll notice first is we've got our sensor status pane on the right-hand side here. And we'll see all the sensors that we have turned on and placed around Kartik's body. We're looking for a green dot. That means the sensor's happy. It's MVN's receiving data. I can tell that we don't have the gloves active yet. So what I'll do, I'll navigate to the fingers tab here. I'll select the glove type, Manus VR gloves. It will automatically assign the dongle ID that we had in Manus Core. If you had multiple, you can drop down and select the appropriate one. You can see here it's updated, so it's including the gloves. It's happy with the data stream. Once we've connected the gloves, we then input the actor's body measurements. And there are 2 ways to do this. You can do it the simple way where you just input the body height and the foot or shoe length. That way MVN can just estimate body proportions based on those 2 values. If you want to be more specific, you can show more, input all those values manually. And you don't have to do this every time you open a project. All you have to do is, well, the first time you load it in, you save out an actor profile. And that's what I've done for Kartik here. So I'm going to load Kartik's profile. We're going to do the short one today. So I'll load, automatically loads in. And we're pretty much set up. The only thing left is to establish the scenario. Now, you've got a couple of options here. Most commonly, it's single level or multi-level. Basically, it's allowing MVN to assume whether the actor is performing on level terrain or if they're on performing on varying levels of terrain. Say Kartik's going up and down stairs, jumping off a bench or something like that. So today we'll go single level. We will start the project and we'll begin the calibration process. So I'll open the calibration window. There are a couple of options to get started. So you can either do this with a technician, where they can manually progress through the prompts, or you can calibrate by yourself and work with the audio prompts, which is typically what I prefer doing. So we'll do the audio prompts today, but to quickly run through the process ahead of time, what Kartik's going to do is start in what's called an N pose, a neutral pose. And that basically means his feet are hip width apart, perfectly parallel. He'll have his arms straight down by his side, as well as his hands, and looking straight ahead. So we'll hold that pose at the beginning. We'll then be prompted to move around the space. So Kartik will walk up and back, find his way back to the origin point that we've established. He'll get back into his end pose, and we'll just ensure that his hips are facing the forward axis that we desire. And that will conclude the calibration. So I might start.
Go to a starting position where you can safely perform the calibration. Stand in end pose, relaxed and look straight ahead for 3 seconds. Now, move around to move and rotate all the sensors. Avoid rapid movements. Processing. Please wait. Now, stand still to apply and finalize the calibration. The calibration process is now complete. You can move freely now.
We'll walk around the scene yet again, so feel free to move around, Kartik. And what this is doing is warming up the system. And basically MVN is continuing to learn the movement of Kartik. So what we want to do is in this walk around, we want to sort of work with the range of motion, bending all the joints. And you can see here we've got some pretty good real-time data. Especially with the foot placement, no real sliding. Feel free to, I don't know, bowl the ball or something. So it's pretty, very accurate real-time data. So now that we've got the full body calibrated, we can then start setting up the stream before we jump into Unreal. So I'll jump into our network streamer. And you can see here, we've already got some streams set up, but if you had nothing here, we just add a stream. We want to ensure that the host ID is set to the IP address of the system receiving the data. So in this case, our Unreal machine. We take note of the port number, because that's the number that we're accepting in Unreal. And then just ensuring that a few of these selections are toggled on. That's quaternion measurement, character metadata, scaling data, finger data, and object data. If you were to stream to multiple devices, you can do so. Just add another stream, set the IP address to the second machine, or if you wanted to send the same, if you wanted to send 2 actors to the same machine, set another stream, change the avatar number over here to the appropriate actor, and you can get a couple of actors streaming out. So that's all that's required in MVN. What I might do is now jump to Unreal and just give you a run through of how to connect that stream of data to Zara's Metahuman. All right, so I have prepared a couple of things in here to save a little bit of time. There is one step that is relatively time consuming, which is setting up the T-pose, but it's once you've done it a few times, it should really take under 5 minutes. It shouldn't take that long. So basically, as we come into Unreal, the first thing we want to do is jump into our live link window. We want to add a source. And we want to navigate down to the Xsens live link source. Here's the port number that we saw, we noted down earlier. We accept that. And what we want to see is a green dot from MVN. I'll navigate back to that. But basically with that set, I will find my way to the mesh skeleton for Zara's Metahuman. I will create an animation pose. Creating that animation pose will open this window here. We'll navigate to the first frame. And what we'll do, reposition her skeleton so it's in a perfect T-pose. And once we're happy with that, we will then find our Metahuman base skeleton. We will right-click that. So long as we've got the MVN plugin installed, we'll see this Xsens tab here. We create a remap asset, which will take us to this window here. And it is in this window here that we load in that T-pose that we just created. And I just set, there's a template ready for Metahuman. So I have that selected, I compile, I save that, and that's all done. With that done, we then create a blueprint. In this blueprint, we create a live link pose, which is already in there, but basically you find this, you create it. We'll ensure that Kartik is selected in there. We will connect the two. We'll ensure that the retarget asset is set to this remap that we created earlier. That should already be selected. We'll compile, and we'll save that. Now, I think I've potentially missed a step because currently I'm not receiving the stream. So I wonder if we can just jump back into MVN. I just want to double check if we've got everything set up correctly. So bear with me. I haven't selected stream, so that is my bad. And then if we jump back into Unreal, thank you, there we go. So now we've got a green dot, which means we've got data streaming in, and Unreal is happy. So with that said, let's see if we can get some body animation. So feel free to move around, warm up that system again. And we have full body tracking. There we have it. So I think, yeah, there's another step involved in terms of getting the facial capture on. So I'll leave that to Zara. Zara, if you want to take over there.
Andrew, I have a... Oh, sorry. Hi, everybody. Hi, everybody. My name is Zara. I've been at Tracklab for almost a year now. I've mostly have experience working in performance capture for games and interactive experiences. And since working here, I've mostly focused on body capture and facial capture with Faceware's system here. So Faceware are a markerless, color-based facial tracking solution. So we don't need any markers on our performer. There are a couple different hardware options you can go with. The first would just be a stationary camera, a camera on a tripod, a webcam at your desk, something really simple, very affordable that you can just capture the face. There are some limitations if you're moving your neck, but for the most part, it'll get you a pretty good track. Next option would be the Indie Head Cam, which is an adjustable helmet with a GoPro Hero 7 attached to it, and you record data directly on that GoPro. It does also come with an HDMI to USB 3 converter, so you can wire your GoPro to your PC and stream data in that way. And the last solution, which is what we're using here today, is the Mark IV head cam you can see on Kartik. So we've got 3 helmet sizes with adjustable padding. We've got a belt here, I'll get you to turn around, thank you. So I've got a battery pack here, got a Teradek transmitter here, you turn back around, and that's going to a Teradek receiver over there. And then that's being streamed into our QC monitor. And we would use our monitor to frame the face and adjust the focus and the lighting and the white balance. So on the helmet here as well, we have the camera here. So this is a 4.3 millimeter lens. And so that's to reduce distortion, and it really helps with your animator reference. And the camera also has inbuilt lighting on both sides, so you're getting even lighting across the entire face. So in terms of what we've done with Kartik is we've spent some time adjusting the helmet to his size. I've put some padding in there to kind of make it comfortable for him. And we have framed the face. So if we get into our software, you can see here, we've got his face there as well. I'm going to turn the light on for you, Kartik. Okay, there we go. So we can see we've got our lighting. I've gone ahead and I've adjusted the framing and the focus. And I've also white balanced this camera. Because it's a color-based system, we do want that lighting to be as correct as possible. And we want the color to be all good there. So we've got it in our software. And there are essentially two main pipelines that you can go down with the facial capture system. The first is the more traditional pipeline of recording. So you would record a range of motion or ROM, and you can see a sort of list of what that entails on Faceware's website. And you would record your data for the day, and you would take that into Faceware Analyzer, and then you would create training frames from your ROM. So you'd go in, you'd spend some time marking all of those extreme poses, and then that's basically teaching the algorithm how to track that face. So it's quite a simple process, and once that's done, you can track the face, you can track all your takes. You then take that data and you use the Faceware Retargeter plugin to put that into Autodesk products, Maya or Motion Builder or 3ds Max. So that's one pipeline. And then what we've gone with today is actually the real-time live stream pipeline, which is using Faceware Studio, which we can see up here. So this process is really, really simple, and it's just a really great way to just get it on your Metahuman really quickly. So you can see here in the software, I've on the left-hand side here, we can select our camera type. We've got that set. We've got live or media. So you can record media in advance and just put it in the software. You don't need to be streaming in the data. That's what we're doing today. Got optimized for real-time ticked. And I'm just going to set the camera to 720, and we've got 60 frames per second. Generally, the higher FPS, the better. So we're keeping it at 60 for today, which is a good amount. And I've set professional head cam, and you can also do stationary head cam here. So basically what I'm doing is I'm following up the top, I'm following this process bar here. So the next thing is to track the face. So Kartik, can you just look forward for me, keep a neutral face, and there we go. I've just clicked down the bottom here, calibrate neutral pose. You can relax now. And that's actually calibrated. So if I get you to look to the left, Kartik, and look to the right, and we can see that we've already got a track, just like that, just a click of a button. Really, really simple. So the next step then would be to tune the face, because as we can see on the right-hand side here, everything's just kind of set to a default 100%. And you can adjust these features to really optimize the live streaming process, because this is in real time and we're not doing any animating. This is the moment where you could go in and adjust how that face is moving. So I've already gone ahead and done this, and I can load in my profile. And essentially how I went about doing this was I created a ROM, filmed a ROM, and I went into my Metahuman, and I watched that ROM as I looked at my Metahuman, and I saw how Kartik's face is controlling the Metahuman, and if I needed to adjust anything that way. So there's animation tuning, there's also motion effects. This is really getting into the very detailed process. You can really go in and adjust, reduce, and maximize the amount of each control, and you can have one control controlling another facial part. So that's really a way to get it as customized as possible. And then we can just get into streaming. So I can go into my streaming panel here, and I would tick stream to client up here, and I check my port number. If you were using the same PC in Faceware Studio as you were in your animation, like Unreal or Unity, you don't need to worry about the IP address, but because we're using a different PC, just need to make note of the IP address here. Should be that there. So if I go into Unreal now, should be able to come up here. So Faceware have actually created, essentially the way that we're going to get this animation onto our Metahuman is via a blueprint. So Faceware have actually already created a blueprint for the Metahuman. So this is quite a streamlined process. What we've gone is we've gone onto their documentation, and we've downloaded their blueprint, and we've added it to our content browser. So it's called Motion Logic Faceware Live Link. I've added that in, and I can go to my Metahuman, go to her face, make sure the animation mode is on animation blueprint, and the blueprint we've selected will be this ABP Faceware Live Link one. So click on that. Hopefully that was the right one. Yep. And then we go into our live link, so virtual production live link, and we'll add it in. So make sure the IP address is, yeah, I think I've remembered it now, hopefully. Hopefully that's it. Make sure our port number is the same, and we should click OK. And we're getting our green dot, so we should be streaming in. So if I go play, should be able to zoom in a bit. Okay, Kartik, I'll just get you to, yep. Can I get you to answer a couple questions for me, just so we can see the page? I'll just get you to, oh, thank you, Andrew. Right. Okay, so, how's your day been today?
Awesome.
Yeah, and how are you feeling in the suit?
Yeah, feeling better.
Yeah, yeah, and the helmet too, how's that going?
It's firm.
Yeah,
It's good.
yeah, comfortable?
Yeah,
Wonderful.
comfortable.
Yeah, so as you guys can see in Unreal, we've got facial tracking, we've got the body, we've got full body performance capture in, under an hour, essentially. It's quite a simple process, and there's heaps of documentation for this process online too, which is really, really helpful. So yeah, I'll hand it over and we'll get in some, maybe
Great.
some answers, some questions.
Yeah, thank you very much. And thank you for the team for putting that on. I think everybody can see it is quite a quick and simple process to set it up. There's a lot of, it's not to forget about the knowledge that the team has, but the manufacturers have certainly worked on the software pipelines to make it quite simple for people to implement, whether it's in a studio or an educational environment. It's very quick for people to learn and then show other people in a studio. So I guess this comes to the part of our demo where we open up for Q&A and questions. We can have the Unreal scene up so you can see the character, but if anybody has any questions, feel free to ask. Yeah, we've got a question.
You used Metahuman. What if we have a 3D model that wasn't made with like Metahuman or anything, and it's got more of a 2D look to it? Would it be able to be used in this aspect? Or would we go and use Metahuman?
No, so we've chosen Metahuman because it's quite easy to set up. It's quite general in the way it's set up in the structure of the rig inside of it. If you can rig up, and sorry, I should probably say for the online. So the question online was if there is a 2D character, whether this method can be used for that 2D character. I haven't gone through it myself, but you could certainly look at a 2D animation rig for it. It would just depend on the software you're using and probably how you wanted to animate that. But from a body point of view, you would need some sort of underlying structure to animate that with. What comes out of Xsens is the joint angles, so you can use that to body. And then from a facial point of view, if it's been driven in Unreal or Unity, you would probably have to work around and try work out how to get those controls onto your shapes, because I assume you won't be using blend shapes, but maybe a control system. I wouldn't say you wouldn't be able to, but we haven't gone through the process ourselves. A little bit more. Another question? So the question online, for those online is if the Faceware system uses the Apple AR kit. I believe the answer would be no, because it's proprietary software from Faceware, and they've got plugins for each of the pieces of software or tools that you're trying to stream into. So what Zara has explained from the real-time side of things, you've got a piece of software that will track the face in real time, and then it sends the essentially 0 to 1s for your blend shapes into your tool of choice. And Apple AR Kit is a completely separate package. Yes, so Faceware has a lot done if you want to add anything to it, but Faceware has a lot of documentation around the blend shapes and how that translates from their tracking software into Unreal. Cool. There's a lot of documentation available on how to interpret that. Declan, was any questions online? Integration for Unity. So is there a specific request, or is it just understanding if there is integration via Unity?
Yes.
Okay. Yes, so Unity being the other game engine that doesn't get spoken about as much, but is a powerhouse in itself. The manufacturers that we're demonstrating at the moment, so Xsens, Faceware, and Manus, all have plugins that stream into Unity, and they use their own essentially skeleton system to retarget that data onto your avatar in Unity. So it's all documented and available online on how to stream it to Unreal or Unity. We have a question inside.
Yeah, you mentioned before how the information can be exported into the Autodesk suite. Is that through a file format or the direct plugin? And can it be used to export into a file that say works with Blender, so you can do cleanup or apply animation there?
Yeah, sure. Did either of you want to take the question?
Was it facial specific or?
Facial or whole pipeline. Like I said, that if you can all go targeting to a single instance in Unreal, likely you'll be able to get a clip out of that type of performance or isolate it as needed.
So the question for those online is to get a bit more information about the post process if you're going through motion editing or getting characters not necessarily in Unreal, but through Maya, Blender, any of those animation packages. Would either of you like to?
I mean, correct me if I'm wrong. I assume that comes down to the retarget process and ensuring that the naming conventions are correct. Do you imagine any other steps?
I guess the standard formats, BVH and FBX, you can export out and you would bring those into the motion packages that you're using. Is there any other?
Do you have to use hand tracking in Unity, even if my character doesn't have hands? Looking at the documentation online, it says you need hands tracked. But I guess, do we need the Manus gloves?
So the question for online is, do we need, sorry, you can see it in the chat, but just in case, do you need to do the hand tracking if your character doesn't have hands? It's an interesting question. So in terms of the Xsens gloves by Manus, you don't need the gloves to track fingers. If you don't have the gloves attached, the system will just give you classic paddle hands. And that means that you only need the Xsens body system to capture, and you can stream into Unity, for example. In Unity, I assume that you should just be able to ignore, you would have to create a T-pose with the character, and you might have to just ignore the finger data that comes in when you do your T-pose. So it would depend on how you are retargeting the Xsens data onto your character. But the question about the MetaGloves, you don't have to have the MetaGloves if you don't need them.
Can I say, just because the motion can I see how accurate it is when you cut hands and touch it?
Yeah. Yeah, so we can show that quickly, and then if there's, so the question was just about obviously contact points with IMU systems, and it's going to be a test on what our calibration quickly was like. But with IMU systems, obviously, getting estimates of where those body positions are is quite difficult. So we have gone through a process where we've just put in the body height and the foot size, and it's estimated everything else. So from a arm length position point of view, it will be estimated, we haven't put that in, but from a, do you want to put your hands together? So you can see it is pretty close, and that's just with our measurements put in have not been predefined for the arm length. I'd say with the head, always remember that what you're seeing on the screen, the head is just a reference of a rough head size. So you can see that when he puts his hands on his heads, they are pretty close to the finger positions that they were. And then your retarget, the avatar's head will be different anyway. So you do have to take that into account when you run through retargeting. Was there any other ones online?
Without global position, how much error do you get on the Xsens walking?
Okay. So the question being around the global position, to your point about the IMU systems, it's an estimated global position. Xsens estimates that error rate to be about 1% of distance traveled. So it means that if you're in a studio and you're able to travel, say, 100 meters, when you stop, the system will have estimated the position roughly within 1 meter of where you are. Now, I'd probably just add on a little bit more information. If you're doing takes, for example, the way that you counteract that error rate is to actually zero out your origin. So we've got a little mark on the floor. Xsens defines the origin by the back of the right heel. So when you're going for a take, if you need your origin to be in a specific location and closest to 0 as possible, you would get Kartik just to stand at your origin point in your volume, do an end pose, and you can actually reset or move character to origin, and you can reset the axis as well. So if you have any axis drift over time, that's just a process that you get used to when you're capturing on set or going through, and you need that global position. Any other questions in person or online?
Yep. Just wondering about the data cleanup process. Is this best done in MVN, or is there additional resources to learn some best practices on doing this?
Okay. So the question being about cleanup process for, I assume that was the body, probably the body, oh, sorry, MVN, yeah. So it's the body and the finger cleanup process. Obviously with optical, people are well aware that if you occlude a marker, you then have to clean that marker. With IMU, you can see that Kartik is wearing pants. He could be wearing a complete outfit. So it's not occlusion based, and therefore there's not occlusions that need to be cleaned up. In terms of the cleanup process for MVN, there is a reprocess. So I think Andrew mentioned there are two, for real time, it's a quick, essentially, estimate of the position and the rotation of the characters so that you can get all of that data in real time at 240 Hertz. If you're doing a reprocess for a post-process pipeline, what that means is that the system can actually look at all of the data available and actually goes through and resolves all of that data onto a skeleton. And you might see some slight differences, say, in the spine adjustments. If you're doing a multi-level and there's a little bit of a height difference, it will clean up that height difference. So that's a batch process in MVN. Andrew, could you go to File, please? Actually, sorry, go to Edit. Okay, go to File, and then go Export. And so there's a batch, there's two ways to do it. There's a batch process for the export and a batch process for reprocessing, and the batch export can reprocess at the same time. What you would generally do is the process would be you would capture 40 takes during a day. At the end of the day, you would batch export all of your data. It's a hands-off process, uses multi-threading, so you can have concurrent files going at the same time. And then you would bring that into a program like Motion Builder or another 3D Houdini or whatever you want to actually retarget and motion edit on. And then you can go through and correct any global drift in that piece of software. Sorry, that was a long-winded answer.
Speaking of post-process, can you export like an MVS with a mesh, say to bring into Unreal afterwards?
Again, for...
So if you were wanting to retarget,
Mm.
You bring in that, it matches the skeleton that you have for the Xsens skeleton. So when you bring it internally to retarget it, you can bring in the skeleton and then you can mesh and retarget to that mesh.
Yeah, I don't believe that there is a way, because so the question was about if there's a skeletal mesh that you can bring in as a reference potentially when retargeting.
You need to have a mesh, like a skeletal mesh,
Mm.
that you apply the animation to, and then you can retarget it to another character, any character within Unreal. The mesh that matches this particular skeleton, can you bring that into Unreal?
So there's retarget. You can create a retarget template for the animation, and it's always referencing the same skeleton. So my expectation, Andrew, you might.
You're correct, isn't it? The
Yeah.
base skeleton isn't changing. It's more translating the data to
Yeah.
work with your base skeleton. Does that make sense?
So if you bring in an export, you can reference that same skeleton over and over because it's the same hierarchy. Yeah.
Sorry, I found that that's your process.
Task, yeah. Declan, was there anything?
Yeah,
Two more?
gloves. What sort of raw data do you get from the Manus gloves? Can I reprocess with a different calibration? And how does it work with finger splay and other axes of movement?
So the question is three parts. One is, what is the raw data of the fingers? Can you export with a different calibration? And I'm assuming this is gloves. And then can you show us the splayed movement and what's it like? So Andrew, could you go to the raw data tab? Yep. Yeah. Yeah. Leave one up. Kate, could you put your hands up, please? And just mimic the movement that you're going to do so we can see, very similar to a one-on-one. Can you just do an individual finger movement? So I hope this is answering the question online. This is a view of what the raw data is going to look like. You can record the raw data of the Manus gloves in Manus Core. You just need the Pro version of the software, and that will allow you to record it and export it as a FBX. The second question, let's go to the third one, just while you're up there in terms of splayed movement. Can you just, so splayed movement being opening the fingers in and out, and if you go just into, we have a little bit hard to do on those fingers, but each one of those, it might be even worthwhile. We can record some data and actually send it to you so you see the raw data. That might be a nice way to, rather than trying to visualize it on the stream and see the data come through. But that movement comes through. And in terms of, I think the second question was around re-exporting on a different calibration. Yeah, it's a very good question, and we might need to come back to you on that one. I'm not sure in Manus Core if you can import a new calibration and re-export on that. It's a very good question, and we'll get back to you. Declan, could you just take a note of who asked that question, and we're happy to follow up on that one. Thank you. And you said there was one last question?
Yeah, on facial. Will markers on the face help with facial capture?
Yeah, so will markers help with the facial capture? And in terms of live streaming, the markers won't do anything. The system doesn't register the markers when you're live streaming. If you were using the Faceware Analyzer, if you were going through recording and then post-tracking and animating, the markers would help for an animator reference. So because essentially with Analyzer, you're creating landmarks around the face. So you're marking where the eyes are, you're marking where the nose and where the mouth is. And so what the markers will do is if you're working on multiple takes or you've got multiple animators, it'll make sure that all of the training frames that are being created are going to be the same across takes or across animators. So markers would help animator reference, but the system itself doesn't use them.
Sure. Is there any other questions in the room? No? Any more questions online?
While on facial capture, what is the recommended frame rate?
So as long as it's higher, so we've got ours set to 60 FPS. Generally, it's recommended that your facial capture is similar or divisible by your body motion capture. So say you were filming body in 120 FPS, then just for syncing purposes, it's good to make sure that those are the same. But yeah, so generally, as long as it's a higher frame rate, 60 FPS is a good level to have it at.
In terms of like, so it's based on color detection. So how clean does the face have to be in terms of like, I'm assuming glasses, facial hair, tattoos, things like that?
Yeah, so yeah, you probably would want to take your glasses off. And same with facial hairs. I think a little bit is okay, but a full beard would potentially impact the system. And
So the question, just for
yeah,
online, the
sorry.
question in the room was around facial capture and what the tracking is based on. I'd probably also just add in, it's not based on color, but based on contrast. And so if you have someone with fair features, for example, you can darken those features to help, but adding color doesn't change that tracking of it. But in terms of beard, yes, a beard will struggle to get obviously the other edges of the jaw, which will impact the tracking. And then fairer features, sometimes you do have to just darken it to help it identify those. So someone's asked if we could put some glasses on just to see what it does. I don't know, yeah.
Yeah, maybe on the top.
Yeah.
Does it sit on me?
Yeah.
Yeah.
So you can see it still is tracking, but there's going to be some reflections and other things.
Speaking of only dying. Yeah.
So you will struggle to see the movement. What is the time? So that's been an hour. A couple things. One more question? Okay, go for it.
Can the data from MVN be sent out as OBS?
So the question being, can the data from MVN be sent out as OBS? I'm not familiar with that format. The only thing I think of is OBS being the streaming software. And if that's the case, we're using OBS, but obviously you're just screen capturing the Unreal scene, which then sends it online. The formats that you can export, just in case this helps, is so FBX, BVH, and then you've got the biomechanical side of things. So you've got the Excel data and some of the other formats for biomechanics, probably less applicable here, but there's not a OBS specific format. So I'm happy to, if whoever asked the question, if you want to send us a bit more detail as to what OBS is, we can find out what that sort of pipeline would be.
OSC.
OSC.
Which is a tracking format like MIDI.
Okay. OSC format, my assumption would be no, because I haven't come across it with MVN, but we might go back and actually validate that answer. And we got one more question here.
Just following up on Christine's question, has it been tested on very dark skin? I know some facial tracking has been a bit racist, just because it hasn't been tested on very dark complexions.
Yeah, it's actually a really good question and very valid. I don't have enough knowledge to answer that. I would prefer to find out the answer to that. So we might just take a note and get back to you on that one. The question for online was if the facial capture system has been tested and validated on different skin types. And off the top of my head, I don't have an answer that I want to provide to you just yet, if you don't mind.
I'm just going to add some OBS thing. How do you export FBX in
3D, PPH, not OBS.
Not OBS. Great, thank you. Oliver from Movella has confirmed that the format that was asked about was not a format that we can export in. That is now 3 o'clock or just after. So for the people that have joined online, thank you for joining. Apologies, I believe some people have had some issues with the audio and the video, but we are recording this, so we'll send it out as long as our recording isn't impacted by that. And thank you very much for joining. And then for people in the room, please feel free to grab a drink and something to eat, and then just come ask us some questions, or if you just want to play around with the tech, we can do that as well. Thank you very much.